This is Breaking Down Security, and I am Brian Brake. Welcome back, listener. This is Brian and Mr. Betcher for Breaking Down Security.
What's up, Mr. Brake?
Oh, not much. The heat has finally broken here in the lovely state of Washington, thankfully. It probably is not there down there. It's still summer very much in the Austin area, I'd imagine.
Very much.
Yes, I'm sorry about that. I'm sorry, not sorry, actually, because we don't have air conditioning. At least with the joy of air conditioning, you can, be 68 degrees in your house while it's 90 outside. But, So what you been doing this week? You said you were busy before the podcast started. What happened? What's going on? What's the deal?
Yeah, just working around the house, getting some exercise, that kind of thing. Weeds, grass, trimming trees, that kind of stuff,
Are you helping Mr. Goff at all since he was accepted to DerbyCon for his talk?
No, I haven't helped him with his talk at all.
Nothing to prep or anything?
He's a big boy.
He's grown up.
He can handle it.
He's a grown-ass man.
Yeah.
He knows what he's doing. Yeah. All right. Well, I don't want to leave our guest in a green room any longer than it needs to be. You've heard him before. He's a returning champion here on the BrakeSec podcast. We had him on the first time. I couldn't pronounce his name properly, but I've known him and followed him on Twitter and Facebook, where he's a fantastic network specialist. He teaches classes. He'll be telling us about a little bit about where he'll be teaching in the next few months, and he also kills snakes, surprisingly enough, if you've ever seen his Facebook page. Paul Coggin, welcome back to the show.
Thanks for having me back, guys. I'm excited to be back on.
Yeah, I seen you on Facebook. You were picking up this big snake. It must have been about 4 foot long or something. You were like, "Oh, look at this guy!" I just managed to dispatch him. And I was like, "Yeah, is there anything he doesn't do?" Well, for those of the listeners who did not hear Mr. Coggin speak, could you maybe tell us a little bit about yourself before we get into the topic that we're going to talk about today?
Yeah, so I'm Paul Coggin, got about 20 plus years experience with network security architecture, and currently working on a red team where I'm specialized as the network guy on a penetration test team. When I'm not doing that, I like to do a lot of talks at different conferences around the world.
So why does a red team need a network guy? I mean, if they're popping shells left and right, it seems like they do all the time. What do you add to the flavor?
Well, there's this whole OSI model, the whole OSI stack. And that's a good question. Lots of people are focusing on those upper layers, but you still have the lower layers of the stack that need to be looked at for all the infrastructure, the transport networks. The routing, the switching, all that infrastructure, the network protocols, that all needs to be looked at as well. So that's my area of expertise on the team.
I'd imagine you're looking at things like VoIP systems, maybe the BGP stuff as well.
Yeah, routing, switching protocols, the whole infrastructure. So I'm the SME for that on the team.
Very nice.
It's a very elite team I get to work on. Very, very, very proud to be on this team. So I'm the network. That's my area of expertise. I do everything, but that's the area I focus on.
Very nice. Okay. So the reason we wanted to have you on, and this is a topic that we really wanted to have you on since, well, even before DerbyCon last year. Every time we see you, I keep going, oh yeah, I want to come and have you on the show to talk about this. But it's called software-defined networking. It's very much in the news. There was a talk, an article on the Register a few days ago about the fact that you can sniff various forms of traffic having to do with software-defined networking. But we've been wanted to have you on for a while, so this was a great opportunity to have you on and discuss what software-defined networking is, how to maybe properly implement it if possible, and security vulnerabilities or types of vulnerabilities you might find with that. So Maybe you could give us a little background on what software-defined networking is.
So traditionally, when we go and build out a network with switches and routers, all the different network devices have the data. They have the data plane, they have the management plane, and they have the control plane. Where the data plane is where we do all the forwarding. You have the management plane where you're doing your network management, performance monitoring, and you have the control plane where you have your routing protocols, your switch protocols. When you talk about control plane, think about like device to device communications.
Mm-hmm.
And all of our traditional network devices, our Cisco, our Juniper, our Brocade, whatever Kool-Aid, HP, they all would have the control plane, the data plane, the management plane, all in each device, all that software. So with software-defined networking, we're separating that out so that the control plane is centralized, and all then the endpoint devices that you might be throwing out in your comm closets in your data centers. In the case of software-defined wide area networking, SD-WAN, all of the control expertise can be pulled out for the most part. The majority of it is centralized or maybe distributed for redundancy and reliability, disaster recovery. You could have a distributed, say, cluster type architecture of the control so that you only have to program the network at one place. And you could have a centralized view of the whole network. The whole topology is known and understood from one place. And all the routing, all of the integration with the traditional networks that people like me are used to building, all that integration can happen at the controller, but the controller can control all these endpoint switches with, say, OpenFlow protocol, and totally simplify the network for the most part, so that you could have an application, for example, drive policy down for the whole network, so that you get a whole consistent view of the whole network. So it's going to be very disruptive. Like, I see a lot of pluses to it, and there's minuses. Depending on how it's implemented, if it's how it's architected and it's really thought through well, or otherwise we're going to go and have a lot of security issues and have to fight a lot of fights that we've already been through with traditional networks.
Mm-hmm.
So yeah, you do.
So
like
they're very. You said before we started there were various implementations. The one that I saw that was considered I would say the most free is called OpenFlow. But you said that other organizations have their own flavor. Are they all interoperable with each other, or do you have to use the same distro across the whole network, or can you mix and match?
Well, OpenFlow is standardized, but you might have, you have VMware has NSX, which is a really nice product. If you haven't played with NSX, you can go to VMware's website and they have an online lab that you can use. Mm-hmm. And the NSX product is not OpenFlow. It does its own. It's VMware solution. It's very nice, very very robust. If you're a big VMware shop, it's a really nice software-defined overlay network capability, and they have put a lot of thought into security from what I can see, playing with the software on their website that they offer up for lab demonstration purposes. And then Cisco's got a solution that's more hardware-based. That's more of a Cisco proprietary solution where around hardware where VMware has their software solution. And then you got the OpenFlow that's mm-hmm. more open source, kind of like the spirit of Linux, sure. Be more open. Okay. But all of it is going to be headed toward having APIs that you can write applications and drive your network, which is really interesting. From an old school network guy, having developers getting involved with my network and orchestrating how my network may perform based on different policies and whatever other requirements, rather than just whatever quality of service and routing policies that I provision. It's going to be really interesting to have the network infrastructure tapped into via APIs. It's going to be a new way of thinking for us.
Okay, so you mentioned it's going to interact via API. What is there an example that you can give us on how that connects via API? And I mean, what kind of applications are we talking that developers would leverage to this? I mean, is it like with Python where there's socket programming where you open a socket, you write with the socket, and you close the socket? Is that kind of what we're talking about? Where instead of the developers would open, call the API, and that would make it do something. There's functions in the API.
Well, yeah, the API, they would be able to go and push down how the network should flow, what devices should be able to talk to each other, what kind of bandwidth they would need. You could go in and allocate the quality of service for an application. You might be able to go and lay down a logical network, say for ERP, for your SAP system,
Mm-hmm.
that there would be a logical network defined with policies of how that SAP network is going to define and all the infrastructure that is defined to be in that domain. And then you might have another developers may lay out policy to drive the network for, say, your SCADA system,
Mm-hmm.
for example.
Sure.
Or the whole Internet of Things that everyone's talking about now, with all the sensors. Say it could be a traffic control system. Developers could be driving the network for policies for the whole Internet of Things. And that could come in via Python, C++, Java, however the developers, whatever they want to use for their programming language. But what that's going to come into is on your controller. The developers are going to talk to what they call the northbound interface on that API. And I have not done any programming in that myself.
Mm-hmm.
But what I've been reading is that northbound interface where those APIs happen are going to be offered up to the developers. That is still not totally locked down as far as the standards process yet. Even in the open community, there's a lot of work that's happening there. But there's applications that have been developed. HP has some applications that are available. But there's a lot of work going on in the community where vendors are pushing apps out.
Very cool.
But it's going to come in from that northbound interface and then hit the controller, and then the controller down out of the controller's southbound interface, it will go and communicate with the switches. And then if you have, say, a legacy network, say your controller could talk OSPF, it could talk ISIS, it could talk BGP to your traditional networks to integrate in, say, a new data center, something like that. I kind of see the software-defined networks probably being rolled out greenfield and like data center applications. Initially, probably where we're really going to see software-defined networks rolled out, the quickest is going to be the software-defined WANs, where it's being rolled out as an overlay across MPLS networks and internet broadband networks.
Mm-hmm.
Is probably where we're going to see it fastest rolled out. Where it'll have that controlled architecture with devices with the intelligence stripped out of them, just thrown out, say at department stores, other remote sites. These networks that have large number of remotes will probably be rolling it out first.
Okay.
It's going to be a lot. There's going to be a lot of gains there from an operational cost standpoint. Being an old school network guy, though, I prefer. I like the old days where you needed a network guy to program every device. That whole job security thing.
Yeah, exactly.
But we're going to have. It's going to be okay. We'll learn new skills and we'll adapt and overcome.
Let's touch on that. So if I'm a network engineer, old school, like programming, switches, routers, that thing, or configuring them, firewalls and such. Am I needing to learn these software-defined networks if I'm going to have a job in 5 years?
Yeah, we all need to learn software-defined networking and OpenFlow, and we need to be learning programming language like Python. Python is going to be the easiest one to spin up on. If you guys will remind me, after the show, I will send you some links to a gentleman who offers a free Python for network engineers course periodically.
Okay.
I totally forget his name and his links, but he offers a really good Python course for network engineers. Uh, uh, that's going to be the easiest language for someone that doesn't code to pick up.
Mm-hmm.
But the APIs are going to be open to what, if you already know a language, Java, C++, et cetera, to hit. Python is going to be the easiest, but we're all going to have to be able to communicate if we're network engineers with the application developers, so that we can make this whole architecture work, because it's going to happen.
Well, okay, so I mean,
why do I need to learn? Why do I need to learn a language though? I mean, like you said, C++, Python. Isn't there a GUI where I can drag, one device and to connect them to another, or what?
Well, there's
Why
going to
is
be
it so complex?
well, there's going to be a GUI. It's going to be more GUI based.
Yeah.
The days of programming every device, where the way I came up going and programming all the different routers and switches on the network, that long term that is going to go away, and it's going to be more automated and orchestrated. And there will be a GUI, say, at your controller, but there's going to be that automation piece. And if you want to be the network engineer, you're going to have to understand how that automation is happening, so you can work with that developer to make sure that their code is right. Because somebody's got to understand how all these protocols work and how routing and switching still works and all that integration. Because if the developer is not a network engineer, how do they know that they're rolling out the right policies and services across the network, and they're not going to take the network out because they didn't take into consideration how things may happen with, say, a hybrid integration between a legacy traditional network and your new SDN network. So there's going to have to be a network engineer there that can talk developer speak.
Mm-hmm.
Either the developer is going to have to be able to learn networking, or their network guys are going to need to be able to communicate with developers. It's going to be like where we were years ago when we first started rolling out voice over IP. The voice over IP guys and the PBX guys had to communicate.
Yeah. So
so I see that integration happening.
So the developers are just going to call an API, right? So the API should be fairly well documented. So they would have all the functionality. Are we talking like there'd be problems with like half-assed APIs, or the documentation or maybe there's some extensibility in the API or something that would cause the developer to have that kind of ability?
Well, the developer is that application is going to roll out and instantiate that network. So they're going to need to understand the application could affect traffic engineering, quality of service. Device A and B can talk.
Mm-hmm.
Maybe A can talk to C, but we don't want B and C to talk. Mm-hmm. And so, those type of those communication paths are going to need to be understood and how it's going to be rolled out. Traffic engineering, failover, the reliability, how we want things to fail over, depending on certain scenarios. That's the way you need to network engineer things, and maybe not the way that the developer is going to be used to thinking about things.
Yeah.
So there's going to multicast. Multicast is not going to go away. It's on, so the network engineer is going to need to be able to communicate with the developer about how, understand how multicast is going to be handled across the network by that application that's going to be driving that network. So there's going to need to be a communication between both sides.
So the developer could effectively do a denial of service of their own network if, they weren't, if they didn't code their application correctly and it made too many API calls, or could shut down things like quality of service on the network. Can they override existing policies? I know you said that it wasn't fully fleshed out. Does that mean that the security also isn't there as well? So we can't set like any kind of roles based access or anything like that?
Well, you could, but you got to think about the whole. If you got an application that's driving the network, it's going to be driving the network, and it's going to be orchestrating. And of course, you would hope that one would have a lab where they would test these functions and features. But you could have an application that's going to orchestrate this SDN network that would implement what was equivalent to access control list in routers and switches, basically filters, rules. Those type of things could be rolled out along with quality of service. So whoever is going to be, this application is going to be very powerful and integrated in with the network. It's going to have to be understood. There's going to basically be a trust relationship between that controller and the application that connects on that northbound interface. And that gets in from a security side. That's where, from a red team standpoint, from the InfoSec side, that's where the keys to the kingdom are going to be. The crown jewels are going to be in those northbound applications and that controller, that's where all the good stuff's going to be for targeting. Is if you could get to that controller, if you could get to those northbound applications that are orchestrating the network, or maybe get to the developer workstation where all the code's being written. So it's going to open up some interesting attack vectors.
So Paul, I had went to a ISSA meeting where there was a guy there talking about VMware network. It's the greatest thing since sliced bread. It's a no-brainer, all the cliches. What are the downsides that you see? I know you mentioned a couple, but, for this VMware network.
Well, I'm not aware of a great deal of it's more of your philosophy. I like the VMware product. I like the Cisco product. I like what Brocade is doing. I think all these guys have a good product and a good solution. It's a matter of what flavor Kool-Aid you like. I'm typically a Cisco guy because that's just what I spent 20 plus years learning experience. So I lean toward that. But my experience with the VMware solution is very solid. And with the VMware solution is going to be an overlay. You could go bring in VMware and you could overlay it into your existing network infrastructure and then orchestrate a whole new overlaid network that works however the enterprise needs it to. And it's all based in software and it's all overlaid. And you don't have to involve you may or may not involve depending on, how the organization is organized, might not need as much involvement from the typical hardware network engineers because it's all in software. I guess to answer your question, I see from a VMware standpoint, it's more toward a sysadmin domain, where, say, the Cisco solution is more of a traditional network engineer vein of programming, their routers and switches. Now you just got the big Cisco Nexus 9000 box that they're programming. But if you go with the VMware solution, it's more of a sysadmin domain. It's typically your sysadmin is the VMware guy. So,
or maybe your VMware guy is going to have to learn. Like a lot of companies have a VMware specialist, and their sysadmins, right? Just do the administration of the Linux and Windows operating systems, right? So your VMware guy is going to have to learn networking, right? I suppose.
It's going to help. I would imagine that they'd have at least a CCNA level of knowledge, if not better. So they're going to, because playing with the NSX, it understands routing, it understands VLANs, it understands layer 2 security. The NSX product is really strong, from what I can tell. It understands how to do the microsegmentation, VLAN segmentation, how to do private VLANs and isolate those trust relationships. Say at layer 2, and it's pretty intuitive. I was impressed with the product that I played with in their online lab. It's just from my standpoint, what I don't like about it is it's pushing the network over into the sysadmin domain, away from the network side. And of course, being an old school network guy, I prefer to stay over in the network lane. But it's all converging. It's getting really great. The storage guy, the network guy, the virtualization guy, they're all going to become more and more melded together. We're all going to become more generalist.
Yeah. So Paul, let me ask a question. You've from what I've read on Wikipedia, doing some research before the show here, this has been around since 1995, and one of the first implementations was using Java for API and stuff like that.
Right.
when was the first time that you found a company that was using SDN, or maybe the better question is, what was the first company you found that was using SDN properly, or is that even a thing? Is that like a fairy tale?
So my first exposure to working with SDN, I can't go into details, but I got into it a little over a year ago, maybe 2 years ago. I worked on an SDN project. I had heard conversations about it. I had not seen anybody use it, and my role was more of architecture. The project never got off the ground and got built, but we were just uh, doing some real life prototyping and learning about it. I do not know anyone that has actually implemented OpenFlow SDN. I know the VMware solution, the NSX. I know of a number of people who are using NSX and are looking at rolling that out because it's going to be so easy to bring it into an existing network. They have sysadmin that already understand VMware, that are confident in VMware, and it's just a new piece of software that they're bringing in. And so they're real comfortable with bringing it in and using it as an overlay against their existing networks. I hear a lot of people talking about OpenFlow, but I don't know if anybody has actually implemented it yet. I'll give you a good reference. You're out there looking at links and things. I read not too long ago the Internet 2. The Internet 2 guys were one of the early adopters of OpenFlow, and it built and had their network running on, and they recently went back to MPLS. I don't know. I don't know the all the details, but they went back to MPLS for now. I'm sure when OpenFlow matures more, they'll go back to OpenFlow and SDN. But my understanding is right now is they switched back to MPLS. I found that very interesting. I just tweeted before the show because I came from a background of building telco service providers, MPLS type networks when I was focusing on networking purely, and one of the questions that I've had since I got involved with SDN almost 2 years ago, has anyone built a service provider, a carrier class network that has the robust failover, that sonic level failover, say 50 milliseconds or better recovery? If anyone has built an OpenFlow network that has that kind of recovery capability, because I keep hearing about all these service providers are going to roll out OpenFlow SDN networks because they're going to save all kinds of money on CapEx. And so I'm very curious about that piece. I haven't seen it. I keep hearing people talk about it, but I've not. I'm sure they have it in the labs, and maybe there's some production pilots going. I just have not. I'm just not privy to it. Doesn't mean it's not out there, because it's just not my circles that I run in. Um, I think where you're going to see it first, really, the architecture really rolled out quickly is going to be in the software-defined WAN space. I thought it was initially. I figured it was going to be the data centers. That's what I was reading all the white papers on, and all everything I was reading was more focused on data center. But I think you're going to see it on the biggest scale in the WAN. That software-defined architecture may not be OpenFlow, but it's going to be a software-defined architecture where you've got the control plane centralized, and you got the intelligence stripped out of the endpoint devices, and you're going to be able to orchestrate it all from your primary data centers, and orchestrate all your security policies, your VPN, the failover, but say between an MPLS link and say a broadband backup link. Maybe it's a DSL cable. Maybe it's 4G satellite, what have you. I think you're going to see that happen.
Yeah,
probably faster.
I seem to remember something about an ISP who was trying to get rid of regular routers, and I think they were trying to move more towards this software-defined networking. I need to find that.
Yeah, everything I've been reading there is like a huge number of startups in this domain right now.
On purpose, because they see it as a $1 billion. Well, you said it can be used with IoT, and that's going to be a $1 Brazilian industry. I mean,
yeah, it's going to be huge.
Yeah. Let me ask the question. So you have the traditional network has, you have the workstation, you have your switch that goes to your router, which goes to your cloud, being the internet.
Right. Right.
You've got an app. Okay, so we wipe all that away. We're doing the software-defined networking day. Monday morning, your boss comes in, burn everything to the ground. We're going to do software-defined networking. Okay, so you've got a dev, and he's got an application, and he's going to be doing the software-defined networking bit with all of it. What does the topology look like when he does this? I mean, let's say it's for like I don't know. He's like the next generation Nest thermometer, for instance. So we were talking about IoT there. That's an IoT, hot thing that everybody's going to want to have. They do have them right now. What would a developer who's building the next Nest thermostat, what would the topology look like for him to be able to do software-defined networking? And then we can talk about how he's so insecure that it's not funny.
Well, the logical architecture is you would have your application, say, set on a VM, set on a server, and then it's going to talk to a controller, the SDN controller. And the application is going to talk to the controller on the northbound interface. And then out of your southbound interface on the controller, that's where you would talk to your switches. And again, like your switches would just have a minimum amount of intelligence so that your controller can drive the policies, and whether it's quality of service, access control list, defining the trust relationships. All of that is going to come down from the controller that may be defined by the application. And then you'd have your specialized devices that, say, plug into those SDN switches. And those SDN switches would have whatever kind of interfaces and architecture in them that say an IoT sensor vendor or what have you might be building in. If it's an IoT sensor with a switch built in and they're using the controller to control it, all of that would be orchestrated from the controller, which would receive information from the application. Now, from one of the things that's real interesting, you guys were bringing up VMware and virtual machines. Think about the scenario where the controller, because it's just software, could be, say, running on a Linux distro. What if we don't put it on a straight up server? What if we run that controller in a VM, and all of our SDN controllers are running in a VM? And we have, data centers never have power outages, right? And so maybe it's it's the other guy's data center, not our data center. We've got our controllers running in a VM. The power gets knocked out. The servers have to boot up. Our network controllers, our SDN controllers are in VMs, and the power just got blinked. So now the servers have got to come up. The VM, the hypervisor has got to come up before the network can ever come up. So then the SDN's got to come up, and then the switches come up. That could cause a major delay in recovery, waiting for the VMs to be able to spin back up, because you're waiting for your servers, you're waiting for your hypervisor to boot up, and the switches can't come up because they've lost comms with the controllers. So it's going to be an interesting world of scenarios that we have to think through.
So
from that whole availability standpoint.
So software-defined networking doesn't really need any physical devices at all, really. I mean, everything can be virtualized on in a container or something like that. I mean, from what it sounds like, you could use not even a small embedded system. I actually bought 2 of these because you said this was something you were going to be giving out as a freebie to your classes or something. It's a board. The what do you call it? The Phoenix board.
I don't remember what the board is. There, it's just a Zodiac FX.
The Zodiac FX. Yeah, I got these from Northbound Networks, which is, I believe, a joint in England. Yeah. It's a very, very simple software-defined network router or a switch that it's got quad-fast Ethernet, 100 megabit. I mean, it's very simple. I mean, it's even smaller than my Alix board that I use for OpenBSD. It doesn't appear to have any OS on it because I guess it boots from the controller.
Yes, and I'm going to send you a link on how to get that while working.
Yeah, no, that's cool. I actually thought about I thought it would just be something simple like, oh, you can just give it to somebody and then give it away or whatever. But I didn't realize there was all this additional work to be done on it. So it's actually made in Australia. Interesting. Usually these things are made in China. Okay. So you wouldn't even need to have hardware for a software-defined network. Everything could be virtual in a VM environment. Cisco probably would give you like a VM or something for software-defined network. Am I wrong on this? Does it need any kind of physical devices whatsoever other than a host to run a VM or a container on?
Well, it depends on your architecture. You can run in hardware and software. It depends, like the VMware NSX is all software based. Cisco's solution is hardware based. Now you could certainly take VMware NSX and integrate it with a Cisco environment or say a Brocade environment and overlay it across that. So you have those opportunities to integrate where you get the best of both worlds, depending on your architecture requirement. It really is going to be defined by your requirements of what you need. All hardware, software. At some point, you're going to have to be running on something, right? There's going to be some hardware that's hosting the software. But I would recommend if people don't, if they want something that's even lower budget than the Zodiac FX, before they go buy, say, that 4-port switch, though I highly recommend it. You can get MiniNet. You can go and download MiniNet, and that's a free SDN switch and software where it'll substantiate SDN switches with an SDN controller. And so you can build up a virtual SDN network and a VM on your laptop, desktop computer, so that you can learn SDN and OpenFlow. And you can also go to Open Daylight. That's one of the popular controllers. Open Daylight is real popular in the enterprise space. If you could go and download the Open Daylight controller, and if you're like me and you're interested in the service provider space, the controller, the OpenFlow controller, is popular in the service provider space. It's called ONOS, that I believe you made mention of earlier. So there's kind of two camps out there with the OpenFlow controllers that are real popular. You have the Open Daylight, a lot of the vendors are supporting, and then the telco carrier class vendors are heavy into ONOS. But you can download them for free, and anybody who wants to start learning software-defined networking, OpenFlow, start getting intelligent about it, can download it and start getting smart on it. It's coming. It won't be here tomorrow, but it's coming.
Yeah. Well, this seems like one of those things where it's like they were trying to be first to market, because I was looking at that onosproject.org, and they had a blog post from it's a little over a year, April 3rd, 2015. I haven't looked to see if there was any others, but they were talking about various vulnerabilities. They were talking like XML external entity, so XXE vulnerabilities. It's like what SQL injection for SQL for XML structures. So I assume that the API or whatever it is they uses some kind of XML for formatting.
Okay.
The other one, you can create a denial of service when deserializing malformed packets. I mean, some of the stuff that it seems, I don't know if it's the fact that it's an immature technology, but I mean, they're saying that if the packet that is sent to it doesn't match any forwarding rules, it will just pass the packet to the controller for additional advice. And if the packet is malformed, you can actually cause a denial of service. I would assume it fills up the buffer on the system, and then you can't do anything else at that point.
Yeah. So when the network initially is put in place and is operational, the controller is going to push out the tables, the policies out to all the switches. And so, but if a switch was to get a packet that it doesn't know what to deal with, that has not been defined in its policies, by the controller, it will punt that packet up to the controller and say, hey, what do I do with this? And so that's the scenario. So you might be able to go and affect the network by crafting weird packets that the controller was not ready to deal with. So there's a lot of interesting scenarios. Now, from my traditional way of thinking, from a red team standpoint, is just finding that interface to that controller. Finding those trust relationships to get into that controller or that northbound application, so that you can go and take over and influence the whole network. But there's going to be certainly going to be a surface of attack for crafting packets and trying to influence the controller from the switch, from the data forwarding plane. And then there's obviously at the control plane, being able to influence the controller, or from the application, it's going to be talking to the APIs. It's going to be an interesting control plane. Now, another thing from a security standpoint is if you dig into a lot of the SDN papers and architectures, their recommendation is to have an out-of-band network for orchestrating the SDN network for the controller, so for the controller to talk to the switches. But most people are going to, in the majority of cases, like what we do everywhere today, they'll just have one network that's logically separated for the control traffic and the enterprise mission traffic. And so there's going to be a attack surface there on these internal networks. It's going to be really interesting. And then you think about from the software-defined WAN standpoint, all of that control traffic is either going to be traversing across the carrier's MPLS network, which is supposed to be all private and things like that, of course. And we've talked about that on your last show, my opinions about that, if you're not running your own encryption. But it's also going to be running across the internet in a lot of cases, the software-defined WAN, all that control traffic. Now, if it's implemented securely, it's supposed to be doing TLS, but TLS is optional, especially on these from say the internal networks. When most people talk about OpenFlow and software-defined network, and they're talking about it from an internal data center network. TLS is it would use TLS encryption, but that's optional. So from a security standpoint, we'd want to make sure that we're using TLS and using have that secured, but it's also how a lot of the software-defined WANs are going to work, is use TLS for that control traffic, and then of course you'd use IPsec, et cetera, for the encryption. But you're going to have that initial control traffic that's going to happen between those endpoint devices and the mothership from your remotes back to headquarters. It's going to be interesting. It's going to be interesting. It's going to be very interesting over the coming years to see the type of attacks that come out.
Yeah. Well, I mean, I actually was turned on to this I was listening to Patrick Gray over on Risky Business, and his last talk, he was talking to the Gruck about some SDN stuff. And apparently on 23 August, these Italian researchers, Mauro Conti, Fabio De Gaspari, and Luigi Mancini of various universities over there in Italy, found out that there was a way to build a profile of the target network if you're an attacker, and they says it's called a know your enemy attack, and they can connect to passive listening ports on SDN switches, include for remote debugging, and retrieve the flow table. So what's the flow table do? Is that like hey, this is a history of the packets, or these are the packets that have been sent? Is this like a tap or something on the switch?
So the flow table, a switch, say that Zodiac FX switch you have on your desk, it's going to get its flow table built. It's going to get its flow table from the controller. The controller is going to push down to that switch and tell it how the traffic is supposed to flow between the interfaces. How is it going to forward user traffic? What is the policies? And that whole flow table is what's going to come from the controller. And if you had an application, if you had a developer They would say developing a specialized app to orchestrate the network, say for your ERP system, or say maybe a hospital IoT application. It could go and that could go in and define, put some settings in that flow table for you. And so that flow table is basically just telling you how you're going to forward traffic. Think of it. Remember, you had you had your cam table, your switch table. The switch would learn. Your switch would learn how to forward packets or frames, rather, since we're talking layer 2 at that point. How to switch based on MAC address out which ports. Well, your flow table is going to be coming up from the controller, and then when you start getting into like multicast, then you have a group table. And that could be defined by the controller or by the application talking to the controller and the controller talking to the switch. That's what they're getting to there. But they probably have what they're referring to is that the switches they looked at probably have, like we have a lot of switches especially in the SMB space where you could physically tap in, and it basically is a sniffer port on the switch. And so that's what I assume these guys are talking about, is it's got a span port built into so that you can go and pull traffic and see what's happening. And then, of course, it's going to have an interface most likely for an out-of-band controller connection for the controller to communicate with. But what I've been hearing, what I've been reading, is most of these SDN networks, the control traffic is going to run in band with the user mission traffic, because most networks are not going to want to build a separate network for the control traffic and the monitoring and management traffic. So they will just drop it off into separate flows on the same network, and hopefully they define trust relationships.
Yeah, a lot of what they mentioned in the talk was side channel stuff. Like they were inferring information about the flow table from jitter, which is the round trip time variance, sniffing control traffic, because like you said, TLS is opt in, not opt out, which seems ignorant. Right. I mean, if it's there, they should be able to use it. And they can copy the flow table or memory content of the switch to an external location. So they've got data exfil, of the network that way. So I mean, it seems like there's still a long way to go with getting it. Is there an RFC or something that people can comment on this stuff, or is this just something made up by somebody other than IETF that we don't have any control over?
Well, this is the open. There's a consortium called the Open Network Foundation that is working on this, and people could go and follow, and they're publishing lots of papers and working on these problems, and it's maturing. They're even to the point now that they have an associate level and a professional level certification that they put out.
Really? Okay.
Yeah, and that's what I'm looking at. Okay. I'm looking actually developing some coursework for the InfoSec community.
Very cool.
Around that, because we're all the security guys are going to need to get spun up on this.
Yeah. Yep.
It's coming.
Yeah, there's quite a few places out there to find this kind of information. Actually, Paul, you turned me on to a guy named Ivan Pepelnyak. God, I hope I said that right. I think the J sounds like a nyak. He has a podcast. He's at iOS Hints on Twitter, but he has a podcast that he has called Software Gone Wild. It's on iTunes. He has about 60 episodes, but he does a lot of, and like you said, it's really technical discussions on network related stuff. This guy's quite beardy. I think his CCIE is like 1354 or something like that. So I mean, he's been around for a while, so he's seen a lot of this going on. So if you are definitely interested in understanding the deep dives and wanting to know the deep dives in networks and network security and those kinds of things, you could probably check that Software Gone Wild out. There's a link in our show notes for that. You thought quite highly of this gentleman, Paul, right?
Oh yeah, Yvonne has forgotten more than I'll ever know about networking.
Okay.
He really is. He is that level of a network guy. I actually got to meet him a couple years ago at Troopers in Germany. The ERNW, some other network guys that I highly recommend. ERNW, Ray and his team. Well, they run a conference called Troopers, and I got to meet Yvonne at that conference. Yvonne is he's world class. When Yvonne talks, everybody listens.
Very cool.
If they're intelligent, they listen to Yvonne. He knows his stuff.
Yeah.
He knows his stuff. He actually wrote one of my favorite books on the MPLS.
Is it the MPLS standard? Is it the book you wrote?
I forgot the name of the book.
I'll find it. I'll find it somewhere.
It's a Cisco Press book. It's a very large Cisco Press book. But I highly recommend the Yvonne and ERNW. And there's more and more papers being pushed out. The Open Network Foundation has a lot of references.
Okay. Open Network Foundation. I'll put that in the show notes too once I find it. Open Network. So, Mr. Betcher, you've been awfully quiet. Are you aghast, agog, just shocked and dismayed at the coming netpocalypse, I believe Paul's called it?
Yeah.
Well, you had been talking about this for a while, Paul, and I knew it was coming. I was just, waiting for the opportunity to jump in. But if we have time, I have another question.
No, please. We have a ton of time. So please ask your queries, sir.
So getting back to redundancy on SDN, I mean, typically with your traditional hardware, you'd get a couple of, let's say, firewalls. You get a couple of ASAs, and you'd say, okay, you're primary, you're secondary, and if primary takes a dirt nap, then secondary kicks up, and you'd never know it. How mature is the redundancy on SDN?
That if you're when I was really deep in researching SDN, the controller that I saw that had the most thought toward that was the ONOS project, because it's a carrier. It had to be a carrier grade controller, so the carriers want 5 nines reliability. And it was designed from the ground up to be distributed in its architecture. Where Open Daylight was more centralized, they probably have added a more distributed capability Open Daylight now, but the ONOS from the ground up was thought of for distributed architecture because of the carrier requirements. I would look at those guys if you really want a controller that can withstand up to a really rigid recovery audit, disaster recovery, between data centers and things. I know the carriers are behind that, so that's why I'd push you toward ONOS.
Okay, so for enterprise level stuff, I mean, you were talking Internet of Things, you were talking applications. What kind of throughput can you have with this kind of stuff? I mean, the Zodiac board I've got here has 100 megabit Ethernet on there, which, to be fair, that's not fast, and they mention that on the site that it's not fast because they want to keep the boards cheap, which I'm cool with. I'm entirely cool with. That's why I bought 2 of them. Can we go up to like 10 gigabit? Can we do fiber with software-defined network? Does the medium matter, or are you stopped
the
by
optical? No, the optical guys are into this. Your optical vendors, your layer 1, your the guys who traditionally are building out the DWDM and the optical networks. They're a part of this whole SDN push.
Okay.
They see it, and like Sienna, Adtran, you and I exchanged a couple messages on Twitter the other day where Adtran put out an optical product
Okay.
Based on OpenFlow. So these guys are behind it, and they're not going to be limited by the speed of their optics, because
Okay.
it's just, this is the software, the firmware that they roll out for their box will be able to support it. Now, what you're going to run, what I'm interested in, the reason I threw out that tweet earlier before the show, is what I'm interested in is the overhead in OpenFlow, when that controller has to go out and communicate to the switch talks to the controller, they do their handshake.
Are you worried about latency?
The latency, because you're going from having that control capability stripped out or minimized in the endpoint device, and all of the control is in that centralized device. Now we have that latency.
Yeah.
And we're going to, just what are we going to be looking at? And I know that there's really intelligent engineers that are chasing this problem, and they'll work it out with ASICs and really fast algorithms beyond my IQ to understand. But I'd like to know if somebody got this stuff working beyond the lab and in production yet. Heck, just in the lab, and what are they seeing with recovery?
How many more hops does that add? I mean, right now I get about an 18 to 20 second hop if I'm using wireless at home, and about a 15 to 16 millisecond hop if I'm pinging Google. Depending on those. How many more hops are we talking?
You're not going to see that. You won't see any difference there. This is purely going to be between from a user's flow traffic. They would not see a change in the hop count topology.
Okay.
Because this is just going to be the controller talking to the device, pushing down its flow tables. This is how you're going to operate.
Okay.
And if you got some kind of traffic that doesn't match the policy that I gave you, then the endpoint device would punt it back up to the controller, and the controller would tell it what to do with it. But your traffic would just flow.
Okay.
The end users would never know. They would not know the difference between the networks.
So on a software-defined network, can you have a default deny, or like a typical firewall? Can you say, okay, if this traffic doesn't match anything, don't even bother sending it to controller, just drop it?
Yeah, you could push any kind of policy you want to out there.
Okay.
And you could make that happen down at the data plane. Put that ACL down there, whatever your policies you want the policies to be, and you could have those defined at the controller. Or you may have an application that tells the controller, "This is what I want you to do." And what's really interesting to me, guys, you think about, we were talking about, you got the VM, the overlay, you got the OpenFlow, you got Cisco's hardware. Think about because we're a bunch of InfoSec guys. Since I started looking at OpenFlow and software-defined networking, if we're going to go 100%, say if we go in and build 100% software-defined network, and we've gone all in, and now instead of specialized point hardware devices, firewalls, VPN, everything's in software running in VMs or Docker containers, what have you. If we were to go back with self-healing networks and self-defending networks, I wonder how long it will be before we get to a day that the network could morph and reorchestrate itself based on perceived threats. And we could go and morph the topology at different layers of the stack, say at the optical layer, down at, say layer 0, layer 1, from DWDM wavelengths all the way up to on up the stack up into the routing, based on what our perceived threat of an adversary. You wouldn't see this in a small, medium business, but your extremely large critical infrastructure, say, the 16 domains of DHS is critical infrastructure. Say, a power generator, or large government organizations. Say, I just wonder how far away we would be from being able to have a self-defending, self-healing, software-defined network, so that we perceive a threat either based on intel we've gotten out of band, or we're sensing something in the network. We got intel inside the network, some telemetry data, and we morph the network, and we're able to morph the topology.
I could definitely see something like that with you got an IPS and they notice something on the network. The IPS sends a new policy to the controller, which would then push it out to all the boxes.
Right.
Right. With an email also to the to the dev or the admins and go, okay, this was detected. We sent this to the flow controllers. It was patched at this time. We're no longer seeing any issues on the network, or maybe network congestion. You guys are able to change the quality of service. Or somebody sends an email, hey, my VoIP has dropped down to a 3 on quality instead of 4. So the controller sends out something saying, okay, CEO needs more, needs better quality of service on his VoIP, so everyone else is going to get less bandwidth because he needs dedicated bandwidth. You could almost see that from a technical point of view. I can see very definite uses for using software-defined networks and self-healing networks. That makes a lot of sense.
Yeah, I just been wondering how long would they take before we start seeing morphing from, say, a Docker container all the way down to the optical lambda, and having from a whole system of system standpoint.
Yeah,
I don't know. It's going to be, we're headed toward a really interesting world, and that's where you're going to need you're going to still need network engineers that understand all those protocols and those topologies.
Sure.
Absolutely. To be and that have the skills to bridge the gap to talk to the developer, to help the developer understand how to do the software architecture. It's going to be really interesting.
Yep.
Yeah, it seems like it's going to be a lot harder when you start talking about some dynamic networks like that can change based on what they see.
Yeah.
I think the skill set is going to be going to have an upgrade for those kind of networks.
Mm-hmm.
Yeah.
Yeah.
But for now, it seems like open season on for hackers as far as if there is a software-defined network. Like you said, all you have to do is find that app that controls, the network, and try to go after that.
Yeah. If you could find the developer, fish the developer.
Mm-hmm.
If you could fish the developer that's working with the network guys, instead of taking over a Windows box, take over the whole network infrastructure.
Yeah, exactly. Yeah. And, with us not pushing it out and it still being there and not widely accepted, that allows the bad guys to get out in front of this, ahead of time. So, I think a lot of security is going to have to be at least if not enabled, then included into this, so that in the event that it does become widespread, we'll be able to at least have some protections against bad guys. TLS, I think, is something that should be not optional. I mean, considering how we've shown how well encryption works against a lot of things, I think encrypting that traffic or encrypting that control is definitely something that you should do first thing right after you change the default password or whatever it is you do for your SDN stuff.
I think there's going to be a really good career opportunity for both the offense and defensive guys that grab a hold of this and jump out early and start learning software-defined networking.
Yeah,
there's going to be a lot of opportunities for those who are preparing now before it shows up in the data center.
Yep, that makes sense. Mr. Betcher, do you have any other questions for this fine gentleman?
Yeah, Paul, do you have any advice for practitioners whose security practitioners whose company is going to move into this SDN space?
Well, I can tell you what I'm trying to do. I was talking to you guys before we scheduled the show. Look at getting that Zodiac FX. If you want a piece of hardware, start learning with that. Software, you can download MiniNet. There's a ton of videos on YouTube on how to use MiniNet. Go download ONOS or Open Daylight. Start playing with that. Check out Yvonne's website. He's got a lot of blogs, a lot of really good information on SDN. You can start getting yourself spun up on. Start mocking it up in the lab and start playing with it. We got to start learning it, and at the same time, in parallel, You guys don't let me forget, and I'll give you that contact that does the Python training for network engineers. We're going to have to learn Python. Whether we may not be software engineers, PhDs in computer science, but we're going to need to know how to have a conversation with developers about automation and be able to help troubleshoot and bring value to the whole automation conversation, because it's coming. The days of hand jamming router configs out for 100 routers and hundreds of switches, those days are numbered. It's going to get we're going to get automated. It's going to get orchestrated, and we're going to have to learn some new skills. We might not be a pure software engineer, but we're going to have a good conversational capability with coding anyway. I believe. I'm investing in it. I'm trying to do all I can for the salary continuation program. But I wanted to give credit, though, that term netpocalypse. I was just calling it network apocalypse. And Adrian Crenshaw last year at DerbyCon came up with netpocalypse. He came up with the whole netpocalypse. I used to just call it network apocalypse. But Adrian came up with netpocalypse just for.
Very nice. Are you going to be at DerbyCon this year, sir?
Oh yeah, I will be speaking Friday afternoon. I'll be speaking Friday evening, actually.
Oh, very nice.
So yeah, I'll be speaking. Very fortunate to be invited back again. Those guys are very generous to let me come back and speak again. I love DerbyCon. It's always a good time.
Yeah. Me and Mr. Betcher are going to be there.
Are you? Great.
Yeah. We'll definitely sit down and have an adult beverage. You strike me as somebody who might have an adult beverage or two from time to time.
I'll be looking forward to seeing you guys there. Maybe we all can catch up. That'd be
Excellent.
Great.
Yeah, that would be awesome. Mr. Betcher, if you have any other questions for this gentleman, you don't have anything, sir?
Nope.
Okay. Well, Paul, I know you just said you were going to be speaking at DerbyCon, which if it doesn't coincide with Michael Goff's talk, I definitely will join you in the. It's in a track, right? Not a stable, obviously.
Yeah.
Okay.
Yeah, it's
cool.
a track. It's one
right
of the tracks.
Right on.
Yeah.
Where else are you going to be speaking at? I know you mentioned someplace in Vienna. So go ahead and tell us about that.
I'll be at Hacker Halted in Atlanta in September, and then of course DerbyCon the end of September. Mm-hmm. And then in October I'll be at Tactical Edge in Bogota, Colombia. Ed Rojas is running Tactical Edge down in Bogota. Looking very forward to going down there, and I'll actually be speaking and teaching. I got a network class I wrote. I've taught it at ShowMeCon. It's basically a crash course in routing and switching, everything that Blue Red Team needs to know about routing and switching, from initially programming a router all the way to hacking MPLS in 2 days. Mm-hmm. It's pretty intense.
Wow.
And so after Tactical Edge, I go to Vienna, Austria, to speak and teach at DeepSec. So I'm going to teach the course at DeepSec, and then I'll be speaking as well there. So I'll be hanging out in Vienna.
Very nice.
Very nice.
So you're going to be quite busy in the next. And you said you were even thinking about maybe creating a class for software-defined networks.
Yeah, I'm looking at doing one for software-defined networks because I think our community is going to need something that's more InfoSec focused. Mm-hmm. For Blue and Red Team, so I'm hoping maybe next year to break out a 1-2 day software defined network for Blue Red Team.
Okay.
And maybe based on the Zodiac switch.
Yeah.
Bring that in.
So that's cool.
So working on toward that. So.
I would pay money to go to that. So yes, please let us know if you decide to go ahead through that. So.
Yeah, it's going to happen.
Right on. Okay, well, thank you, Paul, for coming to join us on the show. Mr. Betcher, if somebody wanted to get a hold of you to talk about upcoming appearances or DerbyCon stuff, or maybe even your LogMD application, how would they go about doing that?
Yeah, you can hit me up on Twitter. I accept IMs. So just follow at Betcherpwned, BOETTCHERPWNED.
Okay. Are you anywhere else? Are you on Snapchat or Chat Roulette or anything like that?
No.
Okay. Yeah. All right. So yeah, you can follow Breaking Down Security Podcast. Our official Twitter is @Brakesec, BRAKESEC. And you can follow me on Twitter. I'm @BryanBrake, BRYANBRAKE. We're on Patreon. If you find that you've gotten value from listening to Paul talk about software defined networks, or Sean Malone last week talking about cyber kill chain, or Patrick Haim, who was who works at Dropbox. He was a chief like information officer, I believe.
Information security.
Yeah, he was a CISO guy. Yeah. If you find value in any of those talks, and you feel like you need to leave us a little tip or something, you can support us over there on Patreon for even $1. So that's awesome. Most of that money at the end of the year goes to Hackers for Charity or some deserving charity anyway, because I don't keep it, except for what helps me do hosting costs and stuff for Libsyn. So feel free to hook us up on there. We're on iTunes. You can find us on iTunes. We're in the Google Play Store. We're on Stitcher. We're on the TuneIn Radio app if you so choose. www.breakingsecurity, that's BRAKEING security.com. We have an RSS feed. We're pretty much everywhere. I don't think there's any place you can't get us. We even have a YouTube channel. And we're on SoundCloud. So if you want to get on any of those, you can do that. They're all in the show notes. And that's great. So, Paul, we talked about appearances. How would people get a hold of you on Twitter? I know you're pretty big on the Twitters.
Just hit me at Paul Coggin. I'm real easy to find. Just at Paul Coggin, and hit me up, and if I can answer any questions,
yeah,
I'm glad to help out.
Yeah, this is quite an interesting little topic. So I'm sure people would like to ask some more questions or follow you on there. So that's great. Paul, we do appreciate you coming on. We will definitely, meet up at DerbyCon, and feel free to hit us up again if you've got another topic you'd like to discuss. Networking, like the raw networking, the bits, the levels 2 and 1, and even some of the 3 is just something that I don't think a lot of people, unless they came from that background, know a lot about or do anything with. And in many ways, that can screw you worse than popping a shell on a box. So, that's always something I think we need to learn more about. So if you ever have any more network talks or discussions or anything you'd like to talk about, please feel free to join us.
Okay, I appreciate it. Thank you.
Right on. All right. Well, that was it for this week on Breaking Down Security Podcast. I hope you have a great week, and we'll talk to you again real soon.
Bye-bye.